Hello dear students. Today we are going to solve October-November 2024, but this time paper 6 variant 1. Keep in your mind this paper is called Alternative to Practical, as you can see. Over here the practical skills will be tested. You will have 3 analysis questions, question 1, 2, 3, and the last question will be planning and investigation. So pay attention and try to understand how to approach as per Cambridge standards to each and every question. There you go. First question, let's read. A student investigates the period of pendulum. Figure 1.1 shows the setup. You have the bob of pendulum, which is at distance d from the bench, and the total height of the support from the ground is x. Student adjusts the length of the pendulum until the distance d measured from the bottom of the support of the center of the bob is 90 centimeters. He measures and records in the table 1.1 the time for 10 complete oscillations. He calculates and records in table 1.1 the time period t. The period is the time for one complete oscillation. So the total time which is recorded is for 10 oscillations. While you want to calculate the period t, and that period t is for 1 oscillations. So what does that mean? Whatever is the time t taken, you will divide by 10 to get the period. Okay, so here is the question. Calculate the value of t square and record in the table. So to find t square, this one, you need to get this one. And this one is period. So let's start with the time period, t. So what you do, you divide this number by 10 right here. Also divide this number by 10, you write here, because we want to find period. So the first one is going to be 19.1. You divide by 10, 1.91. And you take it square, 1.91 square, that is 3.6481. So you write with 3 significant figures, 3.65. You repeat the process, same for the next one. You divide this by 10, you write it 1.35, you write it square, you also write it 3 significant figures. Actually, it is 1.8225. You will write 1.823. 82 is enough, being 3 significant figures. Now, the next part is the student repeats the procedure in A using the distance D. Calculate and record the period, we did, and t square we also did. We are already done for both of them. Now they say complete the column heading. What is the meaning of column heading? Column heading means on the top of the column you have to write correct units. So correct units for time, it is seconds. Period of oscillation is also seconds. Since this is t square, so it will be second square. This is how we write it. Let's proceed to the next page. Explain why timing 10 oscillation gives more accurate rather than 1 oscillation. So it's already written, it gives more accuracy. So you can't say for greater accuracy. You have to say if you take greater number of oscillations, it will reduce the percentage error. It will distribute the percentage error over longer time. So you can say 10 time for 10 oscillations or timing for 10 oscillations, it's better. Reduces the percentage error. So percentage error will be reduced because the error will be spread over longer time. So this is the ideal answer. We'll proceed to the next one. Part E. Describe one technique that you use to improve accuracy. When measuring the distance d, you may draw on the diagram. Let's go back and we want to measure the distance d. What can we do to measure this distance d as accurate as possible? Over here, some issues are there. For example, you want to place a meter rule, so it is not easy to set exactly in vertical position. So what can you do? One option is here on the bench, you can use a set square, and then you can align the meter rule next to set square. It will be 100% vertical. Or what you can do, you can hold the meter rule as close to the string or the bob as possible. I will write both of them. So they say you may draw the diagram. I'm not drawing, so I will say use a set square to ensure meter rule is vertical and as close to bob as possible. Okay, our next question is describe one technique that you use to improve accuracy when measuring the time t for 10 oscillations. So whenever you want to measure the time, how can you know the time is as accurate as possible? Please do not write zero error. Okay, check the zero error of stopwatch. Stopwatch we always reset before we use. So you can talk about start always counting from 0 instead of 1. When you release, it's 0. So comes back 1, 2, 3, like the pendulum. It's here, goes there, and comes back. This is one full oscillation. So you can mark a point on a grid. You can count when the pendulum passes the vertical, or you can start from 0. So here is the pendulum, right? So what you can do, you can start counting when the pendulum passes the vertical, okay? Or start counting from 0. It's just like the zero error should be checked out. So you can say always start counting from 0. Next, another one I'm writing for you. Always start counting from a recognizable point, from a recognizable point on oscillation. So that you can know where to start and where to end the 10th oscillation. Anyhow, the pendulum support is 40 centimeter above the bench. Estimate the distance x between the bottom of the pendulum support and the floor. Go back. So they are asking you approximate this distance. Okay, so how much could be this distance? If you go back, they already told you this is 90 centimeter. So the student adjusts the length of the pendulum until the distance d measured from the bottom of the support to the center of the bob is 90. So this one is 90. Yes, and they already told you that this one is 40. So this one is 90 and this one is 40. So what could be the total height? You add them 90 plus 40, which is 130 centimeter. I'm sure you got it. So the 90, they told you already in the question. Over here, I will just label for you that this center of the bob till the ground is 90. And now they told you this distance is 40. So total is 90 plus 40, 130 centimeters. 130 centimeter. Okay. Next question. A student plans to plot a graph of t square against d. Suggest a suitable values of d, which is the distance, as we already talked about, from the ground. The student can use to obtain the measurements are sufficient. So suitable values of distance. Whenever you want to make a plot, there should be at least 5 values. So the distance you can do, please make sure this distance d should not exceed this distance. Like this distance should be less than 130 what you wrote, because 130 is the maximum height. So you can write at least one is already there, so 4 more you can do. So the previous value of d we used 90, so you can change any other number after 90. 100 centimeter, 110 centimeter. You can use one below 90 as well, like 80, 100, 110 centimeter. So why? I will tell you here. Because the total support height from the beginning, it is 130. So the pendulum can be 90 height, 80 height, 120. Don't reach 130. 125 will be fine. Okay, so any other number you can write. You can write another number, 120, but not more than that. With this first question is finished, we proceed to the next question. It is thermometry, thermal physics. Rate of heating and cooling we usually investigate there. So let's see what is this question. A student investigates the cooling of water in a metal container. As you can see, student uses thermometer to measure the room temperature. The room temperature is 23. Clearly show on the thermometer room temperature theta r. So let's see where is 23. We will shade up to that. 23. So here is 20, 21, 22, 23. So this reading is 23. So question is clearly show the reading. So you can go here like that. You can label 23 degrees Celsius. After that, our next part is figure 2.2 shows apparatus set up for investigation. There is bench, water, metal container, thermometer, stand, boss, and clamp. Okay. The student pours 200 centimeter cube of water, hot water, into metal container. She places the thermometer in hot water in the container. She records the temperature at time 0. She immediately starts the stopwatch. She records the temperature every 30 seconds until she has 7 sets of readings. Complete the column headings. Column headings, as I already told you, you have to write correct units. So correct units for time, it is second, and temperature degree Celsius. No, actually it's not second, because they say every 30 seconds. So they are using as decimals. So it means every 30 seconds is 0.5 minutes. So do not use seconds, use minutes. Because it's every 0.5 minute means every 30 seconds. That was a trick. Don't fall for that. Now let's go to the next page. Plot a graph of temperature on y-axis. Okay, so they say temperature on y-axis. Your first task is label theta on y-axis with the right unit. So y-axis is going to be labeled as theta slash degree Celsius. Okay, after that, time on x-axis, go and label the correct unit for time, what we wrote, minutes. All right. Now they ask you, you do not need to start the y-axis at 0. Draw the best fit curve. It's very rare that they tell you to draw a curve so that you are not confused, so they are easy to you. Now, x-axis unit, first of all, let's check. The x-axis is uniform intervals of 0.5, so we can plot them as they are. So here you go, 0, 0.5, 1, 1.5, 2, 2.5, 3. So yeah, we will reach all of them. 0.5, 1.0, 1.5, 2.0, 2.5, and 3.0. Okay, now y-axis, you do not need to start from 0. So let's see what is the suitable scale on y-axis. Y-axis total large squares, we have 1, 2, 3, 4, 5, 6, and 6.5. Okay, 6 squares. And y-axis is here given. I will tell you how can you choose suitable scale. So you can do the largest value on y-axis, 92. Smallest value on y-axis, 74. How many squares? 6. 92 minus 74 divided by 6. So each could be 3 or each could be 5. It's your choice. So this is giving me 3. I can round it up to nearest 5 because 3 is an awkward scale. We don't choose the 3s, the 6s, the 7s, the 9s. We don't choose. So 5 I will choose. I will start from smaller than smallest. Smallest is 74. I can start with 70. So 70, 75, 80, 85, 90, 95. Please continue the scale on. Okay, let's see. Are we covering more than 50%? Certainly. 74 to 92. 74 to 92. It is covering more than 50% of the grade. The Cambridge rule is more than 50%, not more than 70%. Okay. So now let's plot the points. I forgot to label the axes. Both axes should be drawn like that, the way I'm doing. Y-axis, x-axis. The axes are drawn now. Okay. Now let's plot the points. I suggest you to do crosses instead of dots. So first one is 0 and 92. 0, 92. 91, 92 with 0. The next one is 0.5, 86. 0.5, 80, 85, 86. This one is 86, you can see. 2 divisions above 80. 5, it is 86. 1 is 82. 1 is 82. That's 82, okay? 1.5 is 79. Here is 79. 2 is 77. 77. 3 is 2.5 is 75. Exactly here. And finally, the last point is 74 at 3. What you have to do, you have to draw a best fit smooth curve. So as you can see, it's a trend with the decreasing gradient. So you take a pen and do it as smooth as you can. I'm trying to do this way. A little bit of change will be required. So I did a smooth curve for you, as you can see. Mine one is passing through all points. If you are missing one point, it is left up or down, it's no problem. But it is a good smooth curve. Both axes I have drawn. And now we go for the next point, which is, yeah, part D. Student states that average rate of cooling of water decreases as the temperature approaches room temperature. Okay, let's check. Actually, we already know the gradient or steepness is decreasing. So it means the rate of cooling is also decreasing. As you approach room temperature, the temperature fall is like as it is approaching the room temperature, so the rate is decreasing. So let's go, and the answer is yes. Yes, rate of cooling decreases. Reason, as time passes, temperature decreases, and here is the answer: gradient of curve decreases. So as the gradient decreases, the rate of cooling is also decreasing. Let's read the next point. It says, explain why it is good to practice to read the thermometer scale at right angles, like 90 degrees, avoiding the parallax error. Okay. So to avoid line of sight error or to avoid parallax error. So it is to avoid line of sight error, you can say. Which causes random error. If you don't write this one, no problem. The line of sight error you can write. You can also write parallax error. Okay. Now the part F is draw a measuring cylinder that contains water, and to your diagram show how line of sight could be you use to obtain. Okay, so first of all, we draw a measuring cylinder like that. You can make its base like that, and you can make two layers just to say how can you do. One side there will be calibrations like this, like that, and the line of sight error means what? Over here, let me just shade to just show that there is a water. This area I'm just gonna shade for you. Okay, so line of sight error they want. So with the liquid, here is the liquid inside the cylinder. And with the bottom meniscus or next to the bottom meniscus, you will do what? Perpendicular, your eye. If you want to make eye symbol like that. So this is how you avoid parallax error. So measuring cylinder with the liquid and line of sight should be at 90 degree with the level of liquid. With this, we are done with the two questions. Proceed to the question number 3. Optical lenses, easy, my favorite. A student investigates the image produced by a lens. Figure 3.1 shows the setup. So you have illuminated object, you have a lens, and you have a screen. So from here, the image will be casted and produced by lens and go to screen. So first question, as you can see, is on the figure, measure the height h naught of the illuminated object. So you will take your ruler, you will measure this height. I have this paper printed with me to the scale. So when you will use this with the help of ruler, like that, okay? So you will place it and it is giving you, you can read 1.6. 1.6. You can see this, my dear students, from 0 to here is exactly 1.6 centimeters. Okay, so let's take the ruler away and write it 1.6 centimeters. Sorry, what was that? Yeah, 1.6. Okay. After that, they ask us to, the student places the lens at a distance 25. So U is 25 centi, this one. This is not to the scale diagram, by the way. Okay. And he moves the screen until there is a clearly focused image on the screen. He measures the distance V, which comes to be 41 centimeters. Two techniques that you use to obtain a clearly and focused image. One of the technique is already mentioned in the question. Okay? He moves. So when you move until you get clear, so you have to move it gently or slowly back and forth. Okay? So when you move it, you have to move the screen back and forth slowly. The second is anything, because you want a clear image and focused image. So make sure there is no ambient light. So make sure the room is dark. So either you can say darkened room. You can also say the object should be as bright as possible. One of them is okay. These two I wrote. Now we proceed to the next part. Calculate the focal length f using this formula. So go to the previous page. They told you in the question that the u is 25.0 centi and v is 41.2 centi. So 25.0 multiplied by 41.2 over same thing 25.0 41.2. So let's calculate and write to the same precision as 1 centimeter as we wrote before. 25 times 41.2 divided by 25 plus 41.2 is giving me 15.559. So I will write 15.6 centimeters. Make sure you write the unit, and centimeters precision has to be 1 decimal in paper 6. Now we proceed to the next part, which is the right now over here. Which object? The object is brighter than image. Complete the sentences to describe two other ways in which image on screen is different from object. These students go back. It's a convex lens and the screen, the image is obtained on the screen. So whenever you obtain the image on screen, okay, so what happens? It is a real image. And you should know the real image is inverted. Inverted means upside down. Inverted means upside down. Number two, if you try to calculate the magnification, like the object distance is large and the image is, the image distance is large and object distance is small. So it means the magnification means the size ratio will be V divided by U. Scale factor, you can say it is more. So if it is more than 1, which is the case in this case, so it is magnified image or enlarged image. You can say magnified or you can say enlarged image. Because object distance is less and the image distance is far, so that's why. Student repeats the steps in B using the distance 30 and V is 29. Calculate F again. No problem. We substitute 30.0, 29.8, 30.0, 29.8, which is 14.9498. So you can again write to the same number of significant figures as before. So 14.9 centi. State and explain whether your results for focal length F are equal within limits of experimental. Let's check. What was your F1 before? It was 15.6 centi. And now F2 is 14.9 centi. So are they equal or no? I know some students, they think, no, they are not equal. Actually, they are equal. Why? You will find their percentage difference. You will say F large minus F small over F average. You multiply by 100%. Okay, if your answer comes up to 10%, you will say yes. If it comes more than 10%, you will say no. Let's check. So 15.6 minus 14.9 over their mean. Mean I'm calculating. Their mean is 15.25 multiplied by 100. So I'm calculating 15.6 minus 14.9 divided by their mean times 100. The answer is 4.59%. This is less than 10%, so it means the answer is yes. So question is whether your results are equal. So you will say yes, they are, or focal lengths F are equal. Reason, as I told you, percentage difference is within 10%, which is within limits of experimental accuracy. So with this question, we are also done. Question number 11. Now we proceed to the next question and the last question. Certainly, that's a planning question. I want you all to learn planning carefully, no matter how people tell you. My way is the best way because you know that I have been the team for the examiners as well. So, a student investigates the current required to melt different fuse wires. Okay, so you want to investigate the current required to melt the fuse wires. Now, what do you have? You have fuse wires with a selection of different diameters and metals, but the lengths are given. It is already given that the lengths are same. So you cannot write this as a control variable later. You have meter ruler, you have ammeter, you have variable resistor. Okay. So plan an experiment to investigate how one factor affects the current required to melt the fuse wire. Okay. So we have two options to investigate this question. How many options? Two options. One option is certainly either you can use independent variable as diameter, or you can use the nature of material of wire. So certainly I will go with diameter in this case. So first of all, state the variable that you choose to investigate. So variable, I suggest you all to write as tabs. So you say independent variable, underline like that as a tab. So you will say diameter D of the fuse wire. Okay, done. Let's go back. And what's the next point? They won't complete the circuit. No problem. We are okay. This one we are done. It will award you 1 mark. Let's do the circuit. It will give you another mark. Okay. So circuit, certainly we need to have an ammeter to measure the current until it melts, and we cannot change the current until you have a variable resistor. Why do we need variable resistor? To keep increasing current until the fuse wire melts. Okay, circuit is completed, 1 mark. Variable done, 1 mark. Explain briefly how to investigate. This can give you maximum of 2 marks this time. Let's see what to do. So here you write the subheading as procedure. So you start with the wire. So diameter is independent variable. So I will use micrometer screw gauge to measure and record diameter D of 5 different 5 wires of different thicknesses, 5 wires of different thicknesses. Okay, or you can say diameter of given wires. Okay, diameter done. I will connect one fuse wire in the circuit shown. I will turn on the power supply and increase or adjust the current using variable resistor until wire melts. So you keep increasing the current until wire melts. So I will measure and record current reading, or I will record current reading from ammeter. Done. Procedure is done. Now you will say, I will repeat experiment with other wires of different diameters. Okay, procedure is done. Control variable, I mean, the independent variable is done. Our next part is a key variable. So let's write a key variable and you get the mark. To be kept constant. So your key variable to be kept constant. Do not write temperature because temperature cannot be constant. How the wire will melt. Do not write length because length it is already given. It is same. So only option left is metal. Okay. So the type of metal, you can say same type of metal. Same type of metal or metal wire, metal used. Okay, to make the comparison fair. After that, you got 1, 2, 3, 4, 5, 6 marks. Draw the table or tables. It will award you 1 mark. So in table, what do? You give a tab like that. So you write the headings. Independent variable first. Diameter. Okay, slash, it could be millimeters. Diameter is not that thick, okay? Oh, it's wires because we use the micrometer screw gauge. And the current to melt the wire A. This table have to be completely empty. We don't fill. Don't even try to fill the values of diameters, even if you know. It has to be empty. After this, the last part is 1 more mark and you get the 7 out of 7 marks. It is how would you use the results to reach conclusion. So here you go. Conclusion. Again, make a tab. Right. I will plot a graph of current against diameter of wire and observe the trend or compare the reading. You don't have to draw the graph or axis. So dear student, this is one of the best and the model answer. If you need more planning questions, I can solve and upload for you. Thank you for watching. See you next time with the other variants. Take care. Bye-bye.